This is a revision video for AQA GCSE Physics, in which we look at the first part of Physics Required Practical 3. This is where we investigate the impact of changing the length of a wire on the resistance of that wire. By the end of this video, you should be able to describe how to carry out an investigation to determine the resistance of a wire of different lengths. You should be able to recall the equation that connects potential difference, current and resistance and use it in different configurations, and then calculate the resistance based on readings from a voltmeter and an ammeter as part of this practical. In this required practical, we're measuring the resistance of a wire and looking at how that changes as the length of the wire changes. So to make this easier to do, I've attached a wire to this meter ruler using some tape, and then you can see that I've got crocodile clips to allow me to adjust the length of that wire that is being included in the circuit. So since the tape here is sort of covering the 0 mark and I can't put my first crocodile clip at 0, I've put it at 5, and then this one over here is at 95. So the first measurement I'm going to make is going to be for 90 centimetres of wire. Now, to calculate resistance, I need to know potential difference and current. So therefore, I've got a voltmeter to measure potential difference and an ammeter to measure current. So the first thing that I'm going to do is to make a very simple series circuit containing the wire that I'm measuring. And also I've got a battery here made of 4 1.5 volt cells, so giving me a potential difference of about 6 volts, although I am going to measure that with my voltmeter, so I'll know exactly what it is. And also I've got the ammeter here. So if I plug in that circuit, you can see that I've currently got a current of about 0.68 amps. I'm just going to take that out for a second. So we also need to measure the potential difference, which is why we have the voltmeter, but the voltmeter, of course, is not part of the series circuit. It needs to be connected in parallel. Now, strictly speaking, this should be connected across the wire, but that's a little bit fiddly to do, especially with one hand while I'm holding the camera. So because this circuit only contains one component, we know that it is going to receive the full potential difference that is coming from our battery. So actually, I'm just going to measure it across the battery instead. So if I now connect up my circuit, I can see that I've got a potential difference of 5.86 volts and a current of 0.68 amps. So I'm now going to disconnect that. We want to take all these readings as quickly as we can because the wire will heat up otherwise, and that will also affect its resistance. Now, for each length of the wire, I should do 3 separate readings so that I can calculate a mean. So there's my second one, and I can disconnect it again. So each time I disconnect it, the wire will be able to cool back down again. And then I can do a third reading for 90 centimetres. So I've got 5.83 volts this time and 0.68 amps. So now I'm going to disconnect my circuit and I'm going to move the crocodile clip. So currently it's at 95, giving me a length of 90. And now I'm going to move it down to 85. This is still quite hard to do 100. And then reattach everything. And so I've got a slightly lower potential difference, and also my current has also changed. So again, I would do repeated readings and I would carry on all the way down until I have quite a short wire. So I'm going to go down to 35 there. And see that I now have a potential difference of 5.2, oh, it's still going down, 5.25, 5.23 and 1.75. So now I'm ready to take these readings and calculate some resistances. So what would this look like in the context of an exam question? Before you start writing a method for one of the required practicals, or in fact any investigation in the science exams, it's a good idea to identify explicitly what the independent and dependent variables are. Because if you've written a method that doesn't include changing the independent variable, or doesn't include measuring the dependent variable, then you're going to be capped at quite a low mark, even if you've put in lots of other lovely detail. So in this investigation, we're changing the length of the wire, that's our independent variable, and then we're measuring the resistance. Now, obviously, you can't measure resistance directly, so instead you're going to need to use a voltmeter and an ammeter to measure potential difference and current, and then use that V is I times R equation, which is rearranged to be resistance is potential difference divided by current. Now, this is going to be quite a long method, and there's going to be a couple of little variations where you could do things one way or you could do them a different way. So first off, we need to build a circuit. So you build a series circuit that contains the wire that we're going to measure the resistance of, and also a power source. So that could be a battery pack, it could be a power pack, and an ammeter. Now you may have also included in there a variable resistor. I don't actually know any schools where they do, but this is how the exam board recommends doing it. So it's probable that you've seen that in a textbook or a revision guide, and you may have written about it. Then we're going to use a meter ruler and we're going to measure 100 centimetres of this wire and attach with crocodile clips our voltmeter in parallel across that wire so that we can measure the potential difference. We're going to use the voltmeter to measure the potential difference and use the ammeter to measure the current. And as ever, you want to say what equipment you're using to do a particular thing. We want to take those readings nice and quickly because if we leave the circuit connected for too long, the wire may start to heat up and that would affect the resistance. Then you're going to turn off your power supply or disconnect it and then reconnect it and take those measurements again. So this allows us to check for repeatability and to calculate a mean potential difference and a mean current for that same length of wire. So we haven't changed anything yet, we've just done 3 readings for 100 centimetres of wire. Then we can calculate the resistance using V divided by I for that particular length. And now we're ready to change the independent variable. So now we move those crocodile clips and move the position of the voltmeter. We're going to repeat our readings of potential difference and current and calculate resistance for the new length of wire. And we're going to work our way down, probably only as far as 20 centimetres, because if you get as far as 10 centimetres, the wire starts to get hot, which we will get onto. So once we've got all of those resistances for the different lengths of wire, we can plot resistance against wire length and use that to analyse our results. And then in terms of the second part of the question, the major hazard is that if you have high current, then you end up with your wire heating up, it could melt, it could burn you, all those sorts of things. So in order to lower the risk, we need to keep the temperature low and therefore we need to keep the current low. So one thing that you could talk about is using a really low potential difference power supply, because if the potential difference is low enough, then the current will be low as well. But you can also talk about using that variable resistor to increase the resistance of the circuit. So basically, what the exam board suggest is that as your wire gets shorter and shorter, and they only include the part of the wire that you're measuring in the circuit, you use the variable resistor to add back the resistance that you're sort of taking away. So although your voltmeter is measuring just the resistance of the wire, which is coming down, the resistance of the whole circuit isn't changing, and that therefore means that the current stays the same and therefore it doesn't get too hot. In reality, I prefer the method where you're keeping the whole wire in the circuit, but you're just moving your voltmeter, but either one of those would work. Now, in terms of what you're actually going to have included to get 6 marks, there's obviously a huge amount of detail here, but we're going to need to include taking readings with the voltmeter and the ammeter and specifying what those are for. We're going to need to talk about how you would use those readings, so calculating resistance and then processing that data, probably with plotting a graph at the end. We need to make sure that we have actually changed the independent variable. And then finally, because this is a 2-part question, you need to make sure you've done that risk assessment. So if you haven't mentioned that risk assessment, you would be capped at a level 2 answer and you would have a maximum of 4 marks for this question. In order to be able to measure the resistance of the wire, we need to use the equation potential difference is current times resistance, or you might know it in its short form, V equals I times R. As with all of your physics equations for GCSE Physics, you are expected to be able to recall the different units for them. So potential difference is measured in volts, and we would do this with a voltmeter as we did in the practical. Current is measured in amps or amperes and is measured with an ammeter, and resistance, which we're going to calculate, is measured in ohms. In order to calculate resistance, we're going to need to be able to manipulate this equation and rearrange it to make resistance the subject. So the way that we're going to do this is that we're going to divide both sides of the equation by I, which is current. So this leaves us with voltage divided by current is equal to resistance. So for instance, if we measured a potential difference of 12 volts and a current of 3 amps, then the resistance would be 12 divided by 3, and that would give us an answer of 4 ohms. Here are some quick practice questions so you can check that you're confident calculating resistance from this data. So in the first example, 12 divided by 2 would give us an answer of 6 ohms, then 4.5 ohms for the second question, 0.25 ohms for the third, 2 ohms for the fourth, 4 ohms for the 5th, 3 ohms for the 6th, 1 ohm for the 7th, and the answer to question 8 is going to be 3 ohms. So that's it. Hopefully you're now confident in describing how to carry out Physics Required Practical 3B and also how to process the data from the practical. If you did find this video useful, then don't forget to like and subscribe for more GCSE Science videos coming soon.